Hello. Um, we are entering Chapter 9. Before talking about Chapter 9, I posted the Homework 8 walkthrough guys last Friday. Um, I uploaded it as soon as I recorded it because I don't need to wait it until Tuesday, and I thought you might do the homework during the weekend, so I posted on Friday. Please refer to that videos when you do the homework. So we are going to proceed in the same way. I'm going to post chapter 9 videos on this Tuesday and Thursday, and maybe I'm going to and the homework 9 will be available from Thursday when the second wave of videos available. And I am going to post the basic guides for the homework maybe on Friday or Saturday. It is just my plan. It may be delayed, or I may do it earlier. But just understand that's how it will go from now on. So last Sunday, homework 7 was due, but next Sunday there is no homework due. So homework 8 is due by the Sunday in 2 weeks, so that to give you enough time, more time, so all the homework dues are delayed by a week, which isn't good for you. So I'm telling you today, I sent out an email that I found too many students have missed the last homework. So I understand it can be difficult, and the materials become more and more difficult as the semester goes on. Of course, you should be better now than the beginning of the semester. So you may need more help from me. Then please come to the office hours or watch the videos. Start the homework earlier. If you start the homework on the last day on the due date, then nearly there is nothing you can do. You cannot ask for help. So that's typical problems when you to the students who miss the homework. So please feel free to contact me, ask for help, and I will be very happy, very glad to help you. Just surprisingly, there was no student asking for help. Okay, anyhow, let's go. Chapter 9, the title is Hypothesis Testing. Hypothesis testing, this topic will be divided in 2 chapters. So chapter 9 is part 1, the first half of hypothesis testing, and chapter 10 is the second half of hypothesis testing. Maybe this chapter is most counterintuitive chapter, theory in statistics. Otherwise, all the other chapters are about algebra and a little bit of formula. But hypothesis testing requires a new thought process, a new framework to understand what we are doing. So I spent 2 chapters to explain what we do here. So let's start by comparing 2 statistical inference methods. In the previous chapter, we considered estimation as the first and most common statistical inference method. Estimation is simply to guess a parameter of interest without any hypothesis. So without any hypothesis is the difference between testing and estimation. And for example, examples of estimation is like what percentage of voters support a candidate. What is the mean gas price of gas stations in New York City? And hypothesis testing, on the other hand, is to test a hypothesis. It is not directly about a parameter. You already have pre-existing hypothesis about a parameter, and you want to check if it's consistent with the data or not. So, for example, do more than 50% of voters support candidate A? In this sentence, I'm already assuming that 50% is some important level, and I believe that more than 50% of voters support the candidate. And I just want to check if it's true, consistent with the data. And like, is the mean gas price in New York City lower than $3 per gallon or not? So also again, the parameter is the mean gas price, but not only about the parameter, but also we are particularly interested in whether it is $3 or below $3 or above $3. So what's important is the hypothesis, not the parameter itself. Even if it's $10, $20, does not matter. Like, there is no difference between $4 and $10. Both of them still imply the hypothesis is wrong. So anyhow, the answer is simply yes or no. We are not curious about where exactly the mean gas price is or where exactly the probability is. We are just curious if it's above or below or equal to or different from a certain value. We will see more examples later. So, I'd like to start with a very strange question. It's not a statistics question. Suppose that imagine that I am accused of a crime. Suppose that I was accused of killing a person. Someone was murdered, and suppose that I am the suspect. So I have to go to a criminal trial. But actually, there is the evidence that the evidence is not strong enough to show that I was the murderer. So my guilt cannot be proven sufficiently. But on the other hand, I do not have any alibis or any evidence to prove my innocence either. So both sides, the accused, the defendant, or the prosecutor, both sides don't have any evidence. Just they are arguing their argument without any evidence. Both sides have no evidence. In this case, what would be the verdict? What would be the conclusion? What would be the decision by the judge? I'm guilty or not guilty? Who wins? The defendant or the prosecutors? It's not statistics questions. It's just legal, kind of like common sense. The answer is B. I'm not guilty because there is no evidence that I'm guilty. This is one of the most important principles in the modern legal system, saying the presumption of innocence. So that means the defendant is considered innocent until proven guilty. So if there is no evidence at all, I'm innocent, even though there is no evidence for I'm innocent. Even though like it's nearly like even though I'm very likely to be the criminal, but it doesn't imply if the evidence is not beyond the reasonable guess, then I'm still innocent. So the burden of proof is on the prosecution. So it's kind of unfair decision. Basically, you are choosing between innocence and guilt, innocent or guilty. But as you see, innocence is favored a lot relative to guilt because that's the principle. The defendant should be protected from the legal system. So if the prosecutors want to argue that this guy is the criminal, then they have to show that. They have to prove that. So you understand why we are doing this, to protect potentially wrongly sentenced people. But this kind of unfair decision is not uncommon in our daily life. So this kind of thought process can be found in many different contexts. Let's think about another example about paradigm shift. Like science philosopher Thomas Kuhn argues a paradigm framework, which means, so in the old days, so there were two competing beliefs. One is the geocentrism, and the other was the heliocentrism. So geocentrism means that sun rotates around the Earth, and heliocentrism means the Earth rotates around the sun. So Copernican revolution means, so before the revolution, people just believed the geocentrism, even though they don't know anything. Just it looks like the sun rotates around us. I can't feel I am moving, so I believed the geocentrism, even though the evidence was not enough. It was just believed. It's only when it's until when there are too many counter evidences against the geocentrism when we started to believe the heliocentrism. So it took a long time to prove the geocentrism was wrong. There are too many contradictions and many observations accumulates. So anyhow, this is another example of unfair decisions. Like in the old days, people do not compare, do not think, even they may have not thought heliocentrism as an alternative to the geocentrism. Just they take the geocentrism as granted. So this is another similar structure where people do not try to change their belief until there is contradiction. Another example, conservative decision making. So imagine simply when you need to choose an item from two things, and one of them is an item you have used before, but the other item is totally new to you, and you have not used, and you don't have any information about that. So in this situation, obviously, you are going to choose the familiar one because you know you have used it, and unless you are very dissatisfied with that, you are going to use the one that you used to use. You only change to the new item only when something happens, like you are sure that the new item is better, or you are sure that the familiar item was terrible, something like that. So, and this is another example where the comparison is unfair. Even so, like these kind of structures can be embedded in statistics. That's the hypothesis testing. Basically, the two competing things are two hypotheses about the parameters. So, mathematically, formally speaking, you may write the competing hypotheses like this. For example, the true mean, the population mean equals to 0. You believe that the population mean equals to 0, but you want to test it against it's different from 0. Or you believe that the probability is greater than 0.5. You want to test it against smaller than 5. So we put names. The hypothesis that's favored, and like I often say, incumbent hypothesis, which is believed until proven wrong, is called the null hypothesis. It's called the null hypothesis because it's coming from nothing. Even though there is nothing, you believe that. It's just kind of it's a starting point. Even though there is nothing, you believe that. And we usually denote it as H hypothesis 0. Null hypothesis, H null, is our typical notation. And the opposing hypothesis is called the alternative hypothesis. This is the challenger, and only when you think the null hypothesis is wrong, then you take the alternative hypothesis, right? So it's denoted by H1, hypothesis 1. So 0 and 1, you believe 0, and now you believe 0, and you believe H0, but you want to test it whether it is consistent with the data. So And as a result of hypothesis testing, you may have two results. One, reject the null hypothesis and accept the alternative. Two, you don't reject H0. You don't reject the null hypothesis and keep the null hypothesis after the test. So in many textbooks, the second, you cannot reject H0, is usually said as you accept H0, but I don't like this term because it is not active acceptance. Just you could not reject it. You already accepted H0. Just you wanted to see if it's wrong or not, but you continue to keep this. So it's not a new, it's not about acceptance. So it was there. So I prefer saying you did not reject or you cannot reject H0 instead of accepting H0, right? That's just subtle nuance, but it helps you understand what's going on and what we are doing. So I prefer this expression. Anyhow, so you have two results, whether you believe the null hypothesis, which was the incumbent, or you believe you move to the challenger, the alternative hypothesis. So, and the results imply different things. Like when you reject the incumbent hypothesis, that means it's clearly wrong. Remember, the incumbent is very much favored, but you rejected it, which happens only when you have a very strong evidence. So you reject the null hypothesis, the existing incumbent hypothesis, only when there is strong evidence against it, if there is a contradiction in the data. So it's a very strong conclusion. On the other hand, if you continue to have if you keep the same null hypothesis after the test, then it's nothing. There is no change. There is no difference. And there is no difference even if there is no evidence at all. So suppose that from your data, your conclusion may be something like the sample size is too small, so it's not clear which is correct. Still, you keep the null hypothesis. So when you cannot reject the null hypothesis, this action is very weak. It does not say anything. It doesn't mean there is any evidence. So just having the same choosing the familiar item does not require any revolution. So it's a very weak conclusion in that sense. And as I said, by construction, the incumbent is favored. The null hypothesis is very much favored in the decision. So then, on the other hand, when you argue something, you would like to argue a new theory and refute the existing theory, and you want to say something new, then you have to put your theory as the alternative hypothesis. Otherwise, if you put your hypothesis as the null, that means you are favoring your own argument. So even if you cannot reject it, the conclusion is not strong enough. And so to show that your argument has a strong evidence, then you have to handicap your own theory by putting it as the alternative hypothesis. Then if you could reject the existing hypothesis and accept a null alternative hypothesis, which is your theory, then your theory has enough evidence. So that's the basic framework in hypothesis testing. This is a simple summary. The video became too long, so I'm not going over the table. Just read through. Okay, see you in the next video.